Hello and welcome to yet another episode on this channel. Today we will be looking at invertible elements. So let's begin. Let A be a subset of Zn. We say that A is invertible in Zn if the equation Anx is equal to 1 has a solution in Zn. So now what this is trying to say is that if we are given this equation and we want to find x, so in this case we can represent this as by A inverse. So A modulo n times its inverse should give us 1 in that modulo. So if we have such equation which is equal to 1, then it means that A is indeed invertible in Zn. Okay, so we also denote U of Zn as the set of all invertible elements in Zn. So for instance, we know that if we have, say, Z8, this is from 0, 1, 2, 3, 4, 5, 6 to 7. Now, if you are being asked to find the set of invertible elements of Z8, that is when we represent it by this, U of Z8. Now, this will be equal to, remember, when we said the GCD of A and N is equal to 1, we call them what? If A and N, the GCD is equal to 1, we call them co-prime. So now, over here, with the elements listed here, for instance, if we pick 0, is 0 co-prime to 8? No, because the GCD of 0 and 8 is not 1. Now, out of 1 and 8? Yes, because the GCD of 1 and 8 is 1. So we can list 1. 2 and 8, is the GCD of 2 and 8 1? No, so we don't consider that. 3 and 8, yes, because their GCD is 1. 4 and 8, no. 5 and 8, yes. 6 and 8, no. 7 and 8, okay. So now these are the invertible elements of Z8. So Z8 is from 0 to 7, but its invertible element is 1, 3, 5, 7. Okay. Now let's move on to say, for instance, Z20. Z20 is from 0, 1, 2, up to 19. Now with the set of invertible elements, which is Z20, we are going to get 1, 2 is not part, so 3, 4 is not part, 5 is not part, 6 is not part, so 7, 8 is not part, 9, 10 is not part, 11, 13, 17, and 19. So we have Z20 with this, and these are the invertible elements of Z20, meaning that these elements over here have inverses in Z20. So over here, Z20, we said is from 0 to 19. And let me copy this. Okay, so if you want to know the reason why these elements are invertible in Z20, for instance, if we pick, say, A, let's say A is equal to N, we want to see why is A equal to N invertible in Z20, meaning that if we pick, say, for a B in Z20, 9 modulo 20 times that B should give us 1. You understand? So over here, if we pick 0, 1, 2, something, the number that will satisfy this equation is when B is equal to 9. Because indeed, you can see that 9 modulo 20, 9. This is equal to 1. 9 times 9 is 81, and 81 modulo 20 is 1. If you pick 19, 19 times a certain B should give us 1. But this B will be equal to 19 because 19, 20, 19 is 1. Do you understand it now? Yes. So in this case, 8 in Z20, 8 is not invertible in Z20 because the GCD of 8 and 20 is not equal to 1. So I can give you, this is how to find the U of Zn. So for any A of Zn, then the GCD of A and N should be equal to 1. So this is how to find the set of invertible elements of any modulo given. Understood? Okay. Now let's move on to the next part. We have a theorem. So an element A of Zn is invertible if and only if the GCD of A and N is equal to 1. We've already talked about this. So from the previous examples that we solved over here, you see these are the invertible elements. So for instance, if I pick 19, the GCD of 19 and 20 is equal to 1. That is why it is invertible. Okay. Now let's find 1, the invertible element of Z10. 1, 2 is not part, so 3, 4 and 5 are not part, 6 is not part, so 7, then 9. Then let's find Z of 15. So that is 1. 2 is part because the GCD of 2 and 15 is 1. 4 is also part. 5 is in part, 6 is in part, 7 is part. 8 is part. Then we move on to 11. 12 is not part. Then 13 and also 14. Now let's move on to the next one, which is U of Z20. And that's what we've done already. So 1, 3, 7, 'So these are the invertible elements of Z20. Okay, now let's move on. You can also be asked to, for instance, find the inverse of 57 in Z100. If you are being asked to find something like this, what you have to do is you have to resolve this into, say, 57, then modulo 100, multiplying a certain s. Since we are finding the inverse, meaning that 57 is invertible in Z100, so this should be equal to 1. Now, if you remember, when we are doing linear Diophantine equations, we can resolve this equation as 57x plus 100y is equal to 1. And now, how do we solve this equation? That is what we did previously. So in solving this equation, we have to find the GCD. So in finding the GCD, we use the Euclidean algorithm. That is 100 is equal to 57 times 1 plus 43. Then 57 is equal to 43 1 plus 14. 43 is equal to 14 times 3 plus 1. If you move on, you're going to get 14 is equal to 1 times 14 plus 0. So indeed, you can see that the GCD of 57 and 100 is 1. Now, since this is 1, it means that indeed 57 is invertible in Z100. Now, let's solve the equation backwards. So we are going to make 1 the subject, the remainder is the subject, so 1. So we are going to get 1 is equal to 43, which is multiplying 1 already, minus 14 times 3. Then we move on to the next equation, which is this one. So we are making 14 the subject. So 43, 1, minus, in place of 14, we are going to get 57, 1, minus 43, 1, and all multiplied by 3. So 1 is equal to 43 times 4 minus 57 times 3. Okay, now let's move on to the next equation, which is 43. So we are going to get 101 minus 57 1, or times 4 minus 57 3. So 1 will be equal to 100 by 4 minus 57 by 7. Okay. So now, when we have this, remember the last time that we were solving linear Diophantine equations, we got to see that this is the same as writing 100. Sorry, we are dealing in modulo 100, right? Then 4 minus 57, 100, and 7. I hope this is clear. Okay, remember 400 times 4 is 400. Modulo 100 is 0. So in other words, we are going to get minus 57, 100, 7 is equal to 1. And remember, the question is this. So this can also be rewritten as 57, 100 times minus 7 should be equal to 1. But in modulos, we do not need negative numbers. So minus 7 over here, modulo 100 is equal to 93. So this is the same as writing 57 modulo 100 times 93, and this should be equal to 1. So now over here, we want to find x. So meaning that x in this case is 93. So the inverse of 57, so the inverse of 57 in Z100 is equal to 93. Thank you very much. See you in the next video.